Welcome back to the deep dive. We're here to cut through the chatter and really get you those key insights, the ones you need to be properly informed.
That's the goal.
And today, oh boy, we're tackling a big one. A really widespread misconception that seems to be really picking up steam online.
Mm-hmm. Hmm. I think I know where you're going with this.
Yeah, you've definitely heard it, maybe even thought it yourself. This idea that the big AI models we use every day, your ChatGPT, Gemini, Claude,
Yeah.
that they're constantly out there 24/7 scanning the internet in real time.
Like little digital vacuum cleaners sucking up every new web page.
Exactly. Instantly absorbing your latest blog post, your new product page, whatever, and then boom, it's just magically part of their core knowledge.
Yeah. And you see all these tools popping up, right? Promises to, quote, impose your content onto the AI. Or this idea of an LLM.txt file that'll somehow just rewrite the AI's brain on the spot.
It's everywhere. But here's the thing, and this is the spoiler alert. That's absolutely not how it works, not fundamentally anyway.
It's a really appealing image, that instant knowledge update, very intuitive. But the reality, the actual engineering behind it is, well, it's quite different. And honestly, much more complex.
And that difference is crucial, right? Especially if you're creating content or just trying to understand how these things actually know stuff.
Absolutely. Understanding the difference between how they build their knowledge and how they access current info is key.
So that leads us to the big aha moment for today's deep dive. If they're not constantly scanning live, how do they update? How do they get the information to answer, questions about recent events?
That's the million-dollar question, isn't it?
It really is. And that's our mission today. We're going to unpack the actual mechanics behind AI model training and this thing called generative search.
We'll be drawing on insights from experts like Alexander Rodriguez Silva, and even looking at what the AIs themselves say about how they work.
Yeah, we want to clearly separate let's call it the construction of the library, that's the training part, from the querying of the library, which is more like the generative search you see in action.
Giving you that shortcut, hopefully, to being really clued in on this. It's becoming so important.
Definitely. And Alexander Rodriguez Silva's question really frames it perfectly. He asks, basically, how does ChatGPT learn from websites? What's the mechanism? And crucially, are the algorithms for old school web search, SORPs, the same as for this new generative search? Or are they different beasts altogether?
It's such a great question because it cuts right to the chase. It forces us to look under the hood. Beyond just typing a query and getting an answer, we need to understand the how.
Couldn't agree more. It's the perfect way to look at this. Okay, let's unpack this whole fascinating world of AI knowledge. You might think it's simple, but trust me, when you see how it actually works, it gets really, really interesting. Quite clever, actually.
It is pretty ingenious stuff.
Yeah. All right, let's start with the absolute foundational truth here, the bedrock. An AI model's core knowledge, its fundamental understanding of the world, it's not built by constantly scanning the live internet.
No, absolutely not. That's the biggest misconception.
Instead, it's forged during this incredibly long, very resource-heavy, and completely offline process called training.
Right. Think of it less like the AI is browsing the web as we do, and more like engineers are undertaking this massive multi-year project to build this vast internal library inside the AI's mind.
That's a great analogy. Building a library. It's not a casual browse. It's a planned construction project.
Exactly. Meticulously designed, built, populated. It happens before the AI gets deployed to answer your questions. It needs huge amounts of computing power, specialized hardware, really careful data curation.
An investment that's just, well, staggering. Hard to really wrap your head around the scale sometimes.
It really is.
So if we're building this library, what are the bricks? What's it made of? You mentioned data curation.
Right, so it's built from these massive data sets. The AI isn't just learning from random stuff it finds online right now. It learns from these truly gigantic, carefully pre-processed collections of text and code.
Not just raw web scrapes, then.
Well, web data is a huge part, but it's not just scraped and used immediately. It's collected, cleaned, structured over long periods. Take a common crawl, for example.
Oh yeah, heard of that one. That's huge, right? Publicly available web crawl data.
Exactly. It's colossal. Petabytes of raw web data collected over years, a foundational resource for many AI projects. But raw isn't always best.
Because the web is messy. Ads, menus, junk.
Precisely. Which is where things like Google C4 come in the colossal, clean-crawled corpus.
Okay, clean being the operative word there.
Absolutely. They take something like Common Crawl and apply massive filtering and cleaning. They strip out navigation, ads, boilerplate text, duplicate paragraphs. anything that isn't the core meaningful content.
So the AI learns from the good stuff, not the noise.
That's the idea. It highlights the incredible effort that goes into just preparing the data. It's not just about getting lots of data. It's about getting high-quality, semantically useful data. Quality over just raw quantity, in a sense.
Makes sense. You wouldn't build a library out of shredded paper and junk mail.
You wouldn't. And it's not just web pages either. These data sets include vast amounts of digitized books, think Google Books,
Right.
scientific papers, huge amounts of programming code from places like GitHub.
Code too. Interesting.
Yeah, helps them understand logic and structure.
Yeah.
And critically, the entire Wikipedia.
Wikipedia comes up a lot, seen as pretty high-quality, structured data.
Generally, yes. For factual, structured information, it's incredibly valuable for training. So it's this diverse diet of high-quality text and data.
Okay, so who's actually doing the collecting for this initial library build? Are they using the same Googlebot that finds pages for my search results?
Good question. It's related, but different. During this training data collection phase, they use these specialized crawlers. Think of them as the library architects and construction crew.
Okay.
They might be part of the Googlebot family, conceptually, but their mission isn't indexing for your immediate search results page, the SRP. Their job is to gather a gigantic, diverse, but crucially static snapshot of the public web at a particular point in time.
A snapshot, so not constantly updating.
Exactly. It's about capturing a comprehensive body of knowledge as it existed then to feed into that long training process. Not about finding the latest news article from 5 minutes ago for ranking.
Gotcha. And do all AI companies do it the same way? Does OpenAI have its own giant Googlebot?
Well, ChatGPT is quite clear about this. OpenAI says they don't have a global crawler on the same scale as Googlebot.
Oh, interesting. So how do they get their data?
They might use publicly available dumps like the whole of Wikipedia you can download. They also license content directly from partners' news sites, technical databases, that kind of thing.
Ah, licensing. Makes sense.
And they might use third-party tools to access other public data. So different companies can have different approaches, different infrastructure. But the core idea is this massive curated data set built from a snapshot.
Okay, so they've gathered this mountain of data, this snapshot. What happens next? You can't just feed raw HTML into an AI, right?
No, absolutely not. This is where pre-processing and tokenization comes in.
Yeah.
Think of this as the library's cleaning crew and its cataloging department, getting the books ready for the shelves.
Cleaning crew, I like that. What do they clean?
They take the raw content, HTML, text, whatever, and strip out everything that isn't core meaning. HTML tags, scripts, menus, footers, ads, all gone. You want the pure text, the actual substance.
Right. Isolate the signal from the noise again.
Exactly. And then the really crucial step. The clean text is broken down into smaller pieces called tokens.
Tokens, are those just words?
They can be whole words or sometimes parts of words like ing or est, or even individual characters. It depends on the specific model strategy. But the text gets chopped up into these standardized units.
Okay, so it's not reading sentences like we do. It's reading sequences of these tokens.
Precisely. And this is where the learning, the quote-unquote magic, happens.
Yeah.
The AI analyzes the statistical relationships between billions, maybe trillions of these tokens across the entire data set.
Statistical relationships.
Yeah, it learns which tokens tend to follow other tokens. It learns patterns, grammar, facts, context. Even basic reasoning emerges from these incredibly complex statistical patterns in the token sequences. It's building a probabilistic map of how language works.
Wow. So it's not memorizing, it's learning the underlying structure of language and information from these token patterns.
That's a great way to put it. And this, this is where something like semantic SEO really connects deeply.
How so?
Well, semantic SEO is about making your content clear, well-structured, focused on meaning and relationships between concepts.
Right. Not just keywords.
Exactly. And when your content is like that, clean, structured, semantically rich, it becomes much better raw material for these AI models during their training.
Ah, I see. The AI can learn the relationships and facts more easily from well-structured content.
Precisely. You're essentially making your knowledge easier for the AI to digest and incorporate into its understanding of the world. It helps it build a better, more accurate internal library.
And you mentioned earlier this whole library construction, this training, is a massive investment.
Oh, huge. We need to stress this. It's not quick. It's not cheap. It's incredibly slow and astronomically expensive computationally.
Requires enormous computing power, specialized chips, energy.
Massive amounts. We're talking potentially hundreds of millions of dollars for a single big training run, which means It doesn't happen all the time.
Right, it's not
It's
continuous.
periodic. They do these massive training runs, and that gives the AI its knowledge base up to a specific point in time, the knowledge cutoff date you often hear about.
Like Claude mentioning its knowledge stops around January 2025.
Exactly that. It perfectly illustrates this periodic snapshot nature. It's a huge, discrete effort that sets the foundation until the next massive, expensive training cycle happens. It's not a live feed.
That distinction is so important. Foundational knowledge versus live updates. Okay, so that's the library construction, the massive offline training that builds the AI's core brain. But that doesn't explain how it answers my question about, say, yesterday's news.
Exactly. Now we shift gears to the dynamic part. How these systems actually answer your questions in the moment. How they query the library, so to speak. This is generative search in action.
And the key principle here, again, is that it's not suddenly sweeping the live web for your answer.
Right, that would just be too slow, too inefficient for every single query you make. Imagine the lag.
So what's the alternative? How does it get current info?
The key concept here, for many modern systems, is something called Retrieval-Augmented Generation.
RAG. Okay. Retrieval-Augmented Generation. What does that mean?
Think of RAG less like the main AI brain suddenly becoming a web browser, and more like it has a super fast, really smart research assistant.
A research assistant. I like that.
Yeah. This assistant knows how to very quickly find the most relevant, up-to-date snippets of information from existing resources, and then it feeds that information to the main language model to help it form the answer. Gemini had a good analogy,
Oh, yeah.
like having an assistant who sprints to the right library shelf, grabs a couple of relevant recent books or articles, and summarizes the key points for you. The main AI isn't doing the running around, it's getting targeted updates.
Okay, that makes sense. It's augmenting the AI's existing knowledge with fresh retrieved stuff.
Exactly. Augmented is the key word.
Oh, can we break down that RAG process? How does the assistant work?
Yeah, let's walk through it step by step. It really shows the interplay between the trained knowledge and the fresh info. First up, understanding intent.
So figuring out what I really mean when I ask a question.
Precisely. It's not just keyword matching. The system uses sophisticated natural language processing to decode your query, grasp the semantics, identify what entities you're talking about, even if you phrased it a bit vaguely. What's the actual information need here?
Okay, deep understanding first. Then what?
Then it performs a high-speed preditional search.
Yeah.
And this is super important again. It does not crawl the web right then and there.
Right, you keep stressing that. So where does it search?
It queries an existing, already updated index, typically the index of a major search engine like Google or Bing. These indexes are kept incredibly fresh near real-time by their own separate crawling processes.
Ah, okay. So RAG leverages the existing fast search infrastructure. It doesn't reinvent the wheel.
Exactly. It sends a very specific query to that massive up-to-date index. And the goal isn't to get back a list of links like a normal search.
What's it looking for then?
It's laser-focused on fetching specific snippets, passages, maybe short documents from pages that are highly relevant and authoritative for your specific question. Just the juicy bits needed to answer this query.
Quick targeted retrieval. Got it. What's next?
Contextualization. This is vital. Those fresh snippets it just retrieved, they get passed directly to the main large language model as additional context.
Like briefing notes for the AI?
Perfect analogy. Here's the latest relevant info you need to consider for this specific answer. This is how it provides up-to-date and accurate information, especially for things that changed after its last big training run.
Makes sense. Then the AI has both its base knowledge and this new context.
Exactly, which leads to synthesis and generation. The LLM takes the new context and its vast foundational knowledge from training and it combines them. Based on both inputs, it generates a completely new, coherent response in natural language. And crucially, it's not just copying and pasting from the snippets it found.
It's actually writing something new based on the info.
Yes, it reinterprets, synthesizes, reformulates the information to create a direct, unique answer to your specific question, often more concise than the original sources.
Wow. Okay, synthesis. And then there's one more step usually.
Yes, and it's increasingly important for trust. Citations. The system shows you where it got that fresh information from.
The sources it used for the RAG part.
Exactly. Gives credit, but more importantly, lets you verify the info, see the original context, or explore further if you want to. Transparency.
That whole RAG process really clarifies how they can seem up to date without constantly retraining or live crawling everything. It's a clever combination of systems.
It's very efficient architecture. leveraging the strengths of different components, the deep understanding of the LLM, and the rapid indexing of traditional search.
And it's worth mentioning again that ChatGPT nuance, right? It explicitly says it doesn't crawl in real time unless you activate a specific tool.
Yes, that's a key distinction. The web browsing feature is an add-on, a specific capability you engage. The default mode relies on its training, plus R if needed and available. It's not constantly browsing by default.
And Claude says something similar about using a specific web search tool.
Correct. It mentions using a dedicated tool when it needs current information beyond its knowledge cutoff. Again, highlighting that accessing the live web is a separate, deliberate function, not inherent to the core LLM's operation. Like asking the librarian to fetch a specific new journal, not expecting the whole library to magically update overnight.
That separation of concerns makes a lot of architectural sense. Okay, we've covered the library building, training, and the library querying regenerative search. Now let's get into the tools themselves, the algorithms. This is part 3. The librarian's tools, traditional SRP versus generative search algorithms.
Right, and the core point here, as we've touched on, is that the algorithms driving traditional search, giving you a list of links, and generative search, giving you a synthesized answer, are fundamentally different.
Even if they both use the web as their ultimate source.
Exactly. They're engineered for different jobs, optimized for different outcomes. It's not just a newer version doing the same thing better, it's doing a different thing.
So let's break that down. What does this mean for the classic search experience we all know? Let's start with traditional search, the classic librarian.
Okay, the mission of traditional search is pretty clear. Find and rank the most relevant web pages or documents for your query. Point you to the best sources.
Get you a list of good links.
Pretty much. The process involves crawlers like Googlebot constantly indexing the web to keep that massive index fresh. When you search, complex ranking algorithms swing into action.
Using hundreds of signals, right? Like relevance, authority, backlinks, page speed, keywords.
All of that, yeah. Analyzing the index based on those signals to give you an ordered list.
And the result is the ASER, the search engine results page. A list of links, maybe some snippets, but ultimately it's up to you to click, read, and synthesize the answer.
Correct. Traditional search is about discovery and access. It finds potential answers for you to evaluate.
Now let's contrast that sharply with generative search, the research assistant.
A very different mission here. It's about deeply understanding your query, finding the relevant information, often using RG, and then synthesizing it into a new, coherent, natural language answer for you.
It does the interpretation step.
It does. The process starts with that deeper query understanding we talked about. Then it often uses a hybrid approach.
Hybrid, meaning?
It might just use its pre-trained knowledge if the question is general or historical, like older ChatGPT versions operating within their knowledge cutoff.
Okay.
Or if it needs current info, it does that RAG thing, performs an online search using traditional indexes first, gets snippets, and then feeds that to the language model to generate the answer. That's what you see with, say, Bing Chat, now Copilot, or Google's SGE.
So it can use just its internal library or its library plus freshly retrieved notes.
Exactly. And the result is totally different from a SERP. You get a generated paragraph, an explanation, a direct answer, often with citations. But the AI has done the work of putting it together.
It delivers the understanding, not just the pointers to it.
So if we summarize the key algorithmic differences, it really crystallizes.
Okay, let's do it. First, finality or goal.
Traditional aims to index and rank pages for searchers. Generative aims to train models and generate text answers.
Real-time access.
Traditional crawlers have near real-time access built in. LLMs generally don't, unless using a specific add-on tool like RAG, accessing those traditional indexes.
Response type.
Traditional, a list of links. Generative, a natural language answer. Big difference there.
Core algorithm.
Traditional uses things like PageRank for authority, BERT for understanding query nuances, focusing on ranking documents. Generative uses transformer networks like GPT, focusing on understanding context and synthesizing new text.
And content updates, how they handle new information.
Traditional indexing is continuous, always trying to stay fresh. Generative model training is periodic, happening in discrete, massive batches with those knowledge cutoffs. RAG provides a layer for accessing fresher index data for specific queries, but doesn't change the core training.
Wow, laid out like that, they really are distinct systems with different goals and methods, even though they both rely on the web.
Absolutely. It's the difference between a tool to help you find information and a tool to help you understand and synthesize it. They're complementary, not identical.
Okay, this has been a deep dive into the mechanics, but now the crucial part. Let's connect this back to everyone listening. If you're creating content, running a website, even just trying to find good info online, what does all this mean for you? This is part 4. What this means for content and the future of information, the so what.
Right, the practical implications. And this brings us straight back to the absolute imperative for quality content. Alexander Rodriguez Silva, whose question kicked us off, really hammers this home in his work on semantic SEO.
What's his take?
He argues, essentially, that this whole AI model, how it learns, how it uses RA, massively reinforces the need for content that is incredibly clear, really well-structured, factually accurate, and semantically rich.
So good content practices just became even more important.
Exponentially more important, I'd argue. It's not just good practice anymore. It's a strategic necessity in the age of AI. There's a real dual benefit now.
Dual benefit. How so?
Well, high-quality content obviously still helps with traditional search rankings, getting found on Google. But now it also becomes prime raw material for these generative AI systems using RAC.
If your content is clear and accurate, the AI is more likely to find it during that retrieval step and use it correctly in its synthesized answer.
Exactly. If your content is messy, unclear, inaccurate, it's less likely to be retrieved effectively, or it might be misinterpreted by the AI. So your content needs to be discoverable and digestible by these systems.
And this connects to Alexander's background too, right? You mentioned his expertise in librarianship.
Yes, and this is where it gets really fascinating. His background blends advertising, knowing how to communicate effectively with classic library science, indexing, classification, categorization, skills that are suddenly incredibly relevant again.
Library science for AI.
Pretty much. He draws direct parallels between traditional library tools, things like domain analysis to understand a subject area, using controlled vocabularies for consistent terms, building taxonomies for hierarchy, creating ontologies to define relationships,
Okay, deep library stuff.
and modern AI tools like knowledge graphs, LLMs, and autonomous agents. He sees a clear connection.
So the implication for content creators
Is huge. It means that content which is well organized, uses clear structure, maybe employs structured data markup like schema.org, is semantically rich. It's just much easier for both traditional crawlers and the RG process to understand and use effectively.
You're basically making your content machine readable, not just human readable.
That's the perfect way to put it. It's about structuring your information logically, using clear headings, defining terms, showing relationships, think topic clusters, schema markup, clear information architecture. These aren't just SEO tricks. They're becoming fundamental for AI comprehension.
So the big picture here is content strategy needs to evolve.
Absolutely. It's no longer enough to just think about ranking on a SERP. You also have to consider, how will my information be found, interpreted, and potentially synthesized by generative AI?
You need to be a trusted source for both the classic search engine and the AI research assistant.
Precisely. It means aiming for content that is genuinely valuable, demonstrably accurate, and structured in a way that makes it easy for AI to interpret its meaning and context. It's moving beyond keywords to deep meaning and relationships.
Content creators almost need to become digital librarians themselves, organizing their knowledge effectively for machines, too.
That's a great analogy. It really is a paradigm shift towards higher quality, better structure, and verifiable accuracy being paramount. In a world increasingly mediated by AI, the fundamental quality and clarity of your information will determine its impact.
Okay, let's wrap this up. Time to distill the key takeaways from our deep dive today.
Let's do it.
First, AI training the core knowledge building is this massive offline periodic process, like building a giant library from huge cleaned data sets. It's not live web scanning.
Check. Second, generative search for real-time answers often uses Retrieval-Augmented Generation, or RA. This dynamically queries existing search indexes for fresh snippets and feeds them to the AI as context to generate an up-to-date answer.
Got it. And third, the algorithms are different. Traditional search ranks links for you to explore. Generative AI uses different tech, like transformers, to synthesize a new answer for you.
Yeah.
Different goals, different mechanisms.
Exactly. And knowing these differences really empowers you, doesn't it? It helps you critically evaluate AI answers, understanding where the info comes from, and it helps you think strategically about creating your own content. You can distinguish the deep training from the real-time retrieval.
Absolutely. So here's a final thought to leave you with. The next time you ask an AI a question, or maybe more importantly, when you're creating content yourself, think about this. Are you consciously building a really well-organized, clear, accurate section for what's becoming the world's biggest, smartest library, making your knowledge truly accessible and useful to these systems?
Or are you just kind of tossing information out there and hoping for the best, shouting into the digital void?
Right. What opportunities does really understanding this difference open up for you? How might you change your approach, either as someone looking for information or someone putting it out there?
Something to definitely chew on.
Definitely. Thanks for joining us for this deep dive.
Thanks, everyone.